Hello and welcome to the SaturdayMP show, episode number 98, being recorded live May 11th, 2026. In this episode, we're going to try and write a custom, just write a little C program that'll send a ping packet. And this all spawned because last week's episode, Omar was asking about networking, and he wanted a show about low-level networking. So this is, he asked, and I guess I'm trying to deliver. So we'll see how this goes because I haven't written C in a really long time. I haven't done low-level networking since university. No, I did a bit at a job once where we had to adjudicate dental claims. So I wrote a little server that would parse out. Did it go as low as the sockets? It went pretty low. Like we had to. It was the protocol. I was a big fat binder with how the dental protocol worked and what the each each kind of what each bit meant in the protocol and how to extract the teeth from it and how much the person should get back and all that stuff. So, but that was a long time ago, and I wrote that actually in VB.net because that's what we were using at that particular client. So we'll see how this goes. So thanks, Omar. I don't. Well, maybe not. I don't know if I should thank you yet or not. We'll see how this goes. This might be very embarrassing for me.
No, I'm sure it'll be great. I'm glad you're game. And I've been doing web development for going on like 5 or so years now. And then um it's they always tell you to kind of go one level down from where you're working to kind of develop your understanding a bit better. So when we were kind of looking at the other that the Go application that we've been working on, Postcast, like Chris mentioned, when I saw that we were kind of doing another one of those, like, spinning up an HTTP server using a library in Go or a package. I was kind of just like, okay, why don't we just stop? Because I've done this before in other languages, and uh, I feel like it's time to kind of go one level deeper here, and instead of just kind of like using the packages and the libraries, maybe just kind of try to do it. Well, in this case, Chris will be doing it himself, and I will be watching and learning and maybe chiming in when I can or asking questions. But yeah, I'm looking forward to learning something here.
Yeah. Well, yeah. We'll probably learn something. So maybe that this was a bad idea. All right. So we also have Wireshark. So I'm running this on Windows subsystem for Linux. So I have Wireshark installed there. So you can see here we were testing. So I have Wireshark just set up just to capture ping packets, just so we can see what they look like and we can see what our program is going to be sending out. So I think I have it, yeah, I have it turned off right now, but you can see some of the previous pings that we were sending um, and the replies we were getting back and kind of looking at them. So hopefully when we write our client, we get the same results, but this will be useful as a debugger. Like if we're not getting, like if these don't look, some of this doesn't look the same, then we're screwing up somehow. I also found online, so I was doing some reading this morning, about ICMP protocol, which is what ping requests are sent over. And there's this useful website here, this Inc. It's kind of a cool name, Inc. 00, like it's kind of null or something. Um, about ping and the structures. So they have a little example down here in Python. So I guess worst case scenario, we end up writing this, but so we'll use this to help us. We have the AI set up here, so GitHub Copilot, which we'll try not to use too much because we could probably just ask it to write the whole ping client for us, but we're going to try and learn the old-fashioned way by writing this ourselves. But we might use this to help us write like the make file, or again, I haven't used C in a while. I'm sure there's some sort of like we have to import some sort of library. Is it import? I don't even know the. Oh, include. Oops. Like I have to do include probably some IO or socket. Is there a socket header? I don't know. I'll probably have to include something like that. So if we need to look those up, maybe the clanker can help us here. So, yeah, so let's just see how this goes. So I did a little hello world just to make sure I had C set up in my environment properly, and that all worked. So if I do the a dot out, hey, hello world. So we can, I think we could just delete this. Int main. Okay, I'm just going to copy because I have to remember how this works again. So I need this. Return, say 0. Okay. And then I can just get rid of this. Delete this. Delete this. Okay. So, and I think, let's see. So now I'm going to have to look up the library for, let's see. Oh, I wonder. Let me, hold on for 1 sec. I'm going to roll over here and get my old C book. Oh no, I must have like lent it out or something. I don't know what I did with it. Huh. Yeah, maybe I lent it out to someone. My See a Modern Approach. I lent it to the neighbor for a while there, but okay. Okay, let's just be in ask mode here. What is the C library used for sockets? Oh, okay, there we go. Socket bind. Okay, this looks like what we need. Postex C library. Okay. Yeah, where's my See a Modern Approach, Omar? What did I do with it?
That's a good question. I don't have it.
Okay. All right. So let's just try include. Oh, we'll probably need this anyway. So, let's just see if this compiles. So let's see if I had these. I should have checked if I had these libraries there. I'm just going to do this. So please create a simple make file for this app. Oops. And we'll just do this for now. Turn 0. Okay. Yes. You can go ahead. Test the makefile build successfully. So what's it going to run? It's going to, oh, it's just going to run make. Yeah, sure. Oh, what happened? Did it not run correctly? Let's see. I don't have make. Okay. Okay, that'll probably help. All right, there we go. So now we have this here, and if I probably have to make it executable. Oh no, it already made it executable. Is that part of the makefile? Okay, so it is So source is here. These are the flag. Have you seen a makefile before, Omar?
I have not.
Oh, okay. Again, it's been a really long time, and I'm sure. Well, we don't have any live viewers now, so if anyone is watching this live, I don't know, leave some comments about how badly I'm doing. But or I guess if you're watching this later. But so these are files like, because compiling C applications, like you just have a bunch of C files back in the day, and you'd have to like the compiler, you'd have to put all these arguments and everything, and it was really hard to remember. So this was kind of a shortcut way. So you could just type make, and what the make command would do is it'll look for a file called makefile.
Right.
I think it had to have a capital M. I don't remember anymore. I put a capital M, but and then so these are basically like, you know, like bash scripting or whatever. Like these are basically arguments that you have.
Okay.
And then what it does is it will substitute in those arguments here for what you're trying to do. And then this is like, if I type make, and then this is like what I'm trying to do. So if I try to do this command, if I want to do this, it's gonna execute this command. If I want to do clean, so I could do like make clean. It runs this
Then it
command.
runs.
Yeah.
Yeah, I see. Oh yeah. Okay.
So
So it's kind of like a script.
Yeah. And I guess this dot phony, I've never seen this before. I think is this the default? I don't know what dot phony means. This I'm not familiar with, but and I think the default, there was a way. How do you specify default again? I'm going to quit this. Just clear. Okay, so what is dot phony in the make file? That I don't know. I do kind of like, so you're asking about GitHub Copilot and Claude. Claude used to do this thing, like where it would show what it's like, quote unquote, thinking, but it doesn't anymore. But GitHub Copilot still does it, which is nice.
Oh yeah, okay, so it doesn't do that in Claude.
Yeah, it used to, but not anymore. Oh, okay, this is kind of cool for makefiles. There's an, okay. Oh, that's the other thing make will do too. It'll check to see if there's been any changes to these files that you're trying to compile. And if there hasn't, it won't do anything. And then how?
It won't do anything, as in it won't compile them?
Yeah, it won't recompile everything, because compiling used to be really expensive back in the day. Well, it probably still is for some apps, but yeah, it won't recompile your app if it hasn't noticed anything changed.
I see.
How does make what is the default target if none is specified? Is it just the first one on the command line? Because it's got this target. Oh, target is ping client. Okay. Oh, the default target is target. Make uses the first target. Okay, so this is the first target defined in the file. So we could define other ones, right? Like if we wanted, I don't know, whatever, like a foo, we could do some stuff there. And then oftentimes too, like a application will build a bunch of like object files or like temporary files, and then clean will do more than like these commands can get kind of involved. So okay.
Interesting.
All right. Well, let's do. Let's clean up the get ignore. Oops, I didn't even type that in there. So let's ignore ping client, because I don't want to accidentally commit our make. I don't want to accidentally commit this. Okay, so we're ignoring that. Okay, good. Right? Yeah. Okay. What do we got? Basic app with make file. Okay, good. Okay, so everything compiles. That's great. I can get rid of this. I can get rid of this and this. Okay, so we got our socket. So now we have to figure out. We need to. Oh, okay. Should I turn this off? Let me.
Yeah, I think so, because that's kind of defeating the purpose a little bit.
I'm going to snooze for. There we go. Eagerness auto. Okay, yeah, I'll turn it off for a bit. So
Sorry, how are you checking your usage? There's like a command. I guess I could look it up, but you typed something usage into the Copilot.
oh, there's like so all these agents they'll have like a slash command, and then it's got like all these built-in commands you can run. And I think Copilot has a usage, yeah. So it just shows how much I've used, which isn't really helpful. Like I want to know like how much I have left, so that doesn't really help me.
Yeah, that's what I was wondering about. Yeah.
Okay, so now the kind of the first thing I think we need to do is we're going to need to open up a socket is what we're going to need to do. So let's see if we can do that. Okay, and just so I don't spend forever reading, how do I open a socket?
Yeah, and just tell it not to write the code, right?
Please don't write the code. Just tell me how.
Yeah.
Okay. This is where I was hoping I could find my book. Yeah, I don't know what the heck I do with it. I guess I could look it up too. I guess I could go here. See socket library. Docs. Oh, the man page. Okay, we'll see what the man page says. These are always super hard to read. Oh, at least I did. Oh, and this one doesn't even have any examples. That's sad. Okay. Okay, but basically
It says an example is shown somewhere else. It had like a link to some Yeah, there's under the examples section.
Errors, standards, history. Yeah, examples. Oh, get address info. Okay, so socket. Okay, let's see if this has a better example. Oh yeah, we're gonna have to create a buffer and everything. Oh, I guess I should make this a little bigger. Where are they writing that to? Oh, okay. So there's the socket they're opening. Oh, but it's not. There's no socket opening drug. It's using this get address info. Okay, well that didn't really help. Okay. Okay, so we have to call socket. So let's do this here too. Opening socket. Da, da. So the domain. So we want this. We want IPv4.
IPv4, yeah.
That we definitely want. I guess we could do a raw socket. Sure. Let's go crazy. And then ooh. So if we put the socket, let's go look here. If we put the type of socket in there, because we want to do this kind of from scratch. If we put the type of socket, domain in protocol, an endpoint returns a file descriptor that returns the file descriptor returns. So it's called below. Okay, it's fine. The domain.
So the socket is basically what we need to be able to, like, we're pinging this, like.
Yeah. So what this, if my understanding is correct, what this socket will do is it will ask the operating system to give us a. Do we have to specify the port later? But it's basically just a way for us to read and write. And then it should open up a port, or we might have to do that manually, where we'll tell it, like, hey, when you write to this socket, like, send this data. What's the best way to explain this? Oh, I guess you can send. Oh, wow, you can even send packet level. Okay, so this is telling us what the level we want the socket to be. Wow.
I see.
This is Linux kernel. Yeah, the socket is what we're going to use to communicate. So you can actually use sockets on the same box, like in the same machine.
Yeah.
So you can have two programs running that will open a socket and communicate with each other. But you can also have a computer talking to another computer. It'll open up a socket, and that'll open up a port, hopefully on the machine, and then use that port to send to another machine, and then that machine will send messages back. Okay, that's a good question though. Like, what? I should probably use a socket in programming. Maybe. See, now, Omar, people are finding out I don't know anything. Okay.
You know, I'm sure you know more than than a lot of, you know, people that have built great careers. I think have built great careers over not knowing all kinds of stuff.
Okay, in this context, a socket. Okay, so if you're talking about TCP/IP, which we are, a socket is your IP address and port number, but it doesn't have to be. Okay, because like I said, you can do. I'm pretty sure back in school we wrote like 2 apps that had to communicate using sockets, just with each other on the same machine. Yeah, the inter-process communication. Yeah. Oh, I guess it comes from the electrical world. Yeah, so application communicator with a remote process, socket address. Okay. Berkeley socket standard. Oh, wow. Yeah, sockets all over the place. Okay. Right, so it's create a new socket for this IP address, port 80. It's going to write out this. And the idea is kind of like to treat these like a file or like a stream, I think. So you just write
Right.
to this stream or to this file, and then you just sit there and listen for stuff to come back.
Mhm.
Oh yeah. Here's a C example. Internet. I think this is TCP/IP. I'm assuming. We're opening up a streaming type of socket. Can't remember what this last one is. This is port 80. We want to send to this address. And then we connect to the socket. It'll fail. Then we'll send the message. Because it's C, we have to tell everything how long the message actually is. What's our message that we're sending? Oh, just hello world. And then, of course, you have to close everything when you're done with it. So I don't know. Did that help? Reading the Wikipedia page?
There's a lot there to dive into. So I mean, yeah, this is obviously everything here is going to be on some kind of high level, and then this will be good start to kind of dig in more, you know.
Okay, well, maybe we'll define it better at the end. So, whoops, go back here. So the type of socket we picked was raw, but there's stream, datagrams, obsolete. Oh, interesting. Okay. I'm just going to ignore this type argument here. Types, do we want to stream? Full duplex byte streams. Do not preserve record boundaries. I don't think we want this. Like a full stream.
Okay.
Keep alive. Errors. Okay, well, let's just try raw. We'll see how that goes. Okay, and then what was the last argument for our, it was the protocol. So you can, I didn't see this option in here. Protocol. Okay, so here. The protocol specified tree protocol used with the socket. Normally on a single protocol exists to support pretty good. Specified as 0. However, it is possible that many protocols may exist. Communication domain. Okay, let's see. Oh, just list all the protocols. I guess it's, oh, then, okay. We could give it, oh, okay, this is just a mapping of the like official protocols, it looks like. So we know that like HTTP is over TCP IP port 80. Okay. Okay, let's just try raw and we'll just put it 0. So, 0. No, there we go, 0. Semicolon.
These protocols are essentially kind of like the established kind of forms of communication or standards that for the network, like for machines. Yeah.
Yeah, I think so. Okay, I don't remember how this works now. Please update the make file to build and run to have a target to build and run. Yeah.
This make file is looking a little bit like a YAML file.
Yeah, kind of. Oh, just ./target. Okay. So I think this is, if I remember correctly, like to run this target means it depends on this one. So it'll go back to this one, which depends on our source file. So it'll look at the one source file we have. Run this, and then once it's done that, it'll come back and do this. So, okay, so I should be able to do. I guess we can even put this at the top here. There we go. Now, if we do make it, should just run it. Okay, cool. So open the socket, and then. Okay, so now we should try to. Oh, let's see. Let's try writing to it, and let's see if Wireshark picks anything up. I'll probably have to change it because right now it's looking for all, or just ping protocols. But how would I do that now? Options. I'm just looking for ICMP. Can I specify? Okay, I'll just do all. Let's see. It's going to be like a bunch of stuff's going to appear in here. Okay, I should just do it for my IP address there. That's what I should filter it on. Let's just do this again real quick. Google. Okay. What is my IP address? There it is. So now I should be able to do this. Input. Can I do source? How does this work? Or can I just filter it? How do I filter this one here? View, edit.
Would you be able to tell maybe from once you kind of get the information out which one it is?
Yeah, we could try. We could. Yeah, we'll probably see it. We're not too. It's just a lot of garbage that's up in here. So.
Yeah.
Not garbage, but stuff we're not interested in. Okay, so now, how do we write there again? Let's see. So we open the socket. How do I write to a socket? Is it just write? Okay. Oh, just send. Okay. Oh, this is going to return us like a file descriptor or something.
Or with write. There is a write method apparently.
So int sock equals this, or with write. Oh, we can send or write. Oh, you send to since you need to. Oh, then we cut it off. Okay, let's just try. What does send take? What we want to the buffer, what we want to send versus what is write. Let's try send. Okay. No flags. Send n bytes to buff sock fd. Returns a number sent or -1. Okay, so let's so the first thing is the buffer. That's our socket. Oh, we need something to send. What do you want to send there?
Can we send like a message?
Yep. Yeah, we could send a message. Oh man, now I need a string. Strings in C. How do I send a? Just create a string. I do this. Okay. Just call this buffer. Buffer. The length, size of buffer. Semicolon. Oh, semicolon there. Okay. Well, let's see if this even runs. Okay. Well, it compiled. That's cool and ran. Now let's see. Oh, boop. Close all. And then we want. Where's my other one that I want there? Shoot.
Yeah, it's interesting. It printed the like the print statement gets executed at the very end.
Oh, I lost
Seems like.
Oh, I had Wireshark open in one of those terminals. Oops. Sorry, what were you saying there?
Once you ran your main program, that opening socket print statement ran at that was like the last thing that ran, it seems like. Or at least that was the last thing that got printed, like that we could see in the command line.
This opening socket?
Yeah.
Oh, that comes because we have this printf here.
Yeah, but I mean that came at the very end, even though it's like in the function, it's
It's
at
the
the start.
only thing this thing printed out. So this.
Oh, it's the only thing. So what are those other things? Okay, I see. That's the make command.
Yeah. So this is the compile it, and this is the command to run it. So that comes from the
I
make file.
see.
Yeah.
Right. Yeah. Okay.
Zero. Sure. We're just gonna run this thing. Okay. Let's see what happens. Is this us? I don't know if that's us or not. Okay, let's try this again. No, continue, don't save. that us or?
We're looking for raw socket pro. Is it the TLS V? Because it wouldn't be TCP, right?
This could be it here. Looks like a lot.
I thought we like. I thought we told it that or we decided on another protocol. We said it would be or I guess, I'm not sure.
Here's our payload.
I mean, I see what you're saying now in terms of filtering these things out.
That's got to be us there. Yeah, it keeps appearing. Okay. So, yeah, we put it raw socket inet4, so it automatically did a TLS, I guess, for us. Interesting. It tried to send it. I guess it picked a default destination for us, too. Oh, this is like the handshake it's trying to do, I think. It just picked a default, and it's trying to do a handshake, is what it looks like.
Oh, okay.
Maybe that's what it's trying. It's doing this, doing a handshake, doing this. Is it just handshaking protocol? Because it's talking to my... oh, because it's probably trying to talk to my Windows host. Maybe. Okay, we can... So we sent a raw site, and then we didn't send anything else. Okay, so now let's try making this an IPv4 packet a little bit, and let's see if anything shows up there. Because what do we need for these packets here? Yeah, okay, so we're getting, this is, if we look at this TCP IP packets description, that's what it's doing here. I think this is the handshake. Yeah, the three-way handshake.
Right.
Okay, so it's, yeah, it's trying to do a handshake. So, but we put raw, we put AFINet, which should have been IPv4 Internet Protocols. Do we want something else? Apple device. Okay, well, let's see. Let's try putting some IP protocol stuff in there.
Yeah.
So let's, what do we need in there? All right, so I got this thing open here. See if we can figure this whole thing out. So we need the version. What does the ILH stand for? Oh, I have to look that up. All right, I also have this book here too. Let's see. Maybe does it have a little diagram here? IPv6. No, I don't want that. I want IPv4. IPv header fields. What is ILH? Oh, the internet header length is the number of 32-bit words in IPv4 header, including any options. Okay. normal value, this field when no options are present is 5. Okay. Oh, that's why they put 5 here. Okay, because we don't have any, we're not using any special options. Okay, so let's try that. So how do I, oh, okay, I'm going to have to ask the clanker for this too again. How do I build a string?
This might be kind of useful. I just sent the link to the same site that you sent me, but it's the previous concept explained about raw TCP/IP packet.
Oh, let me see. I see the messages. Oh, there we go.
Oh, is this
yeah.
maybe you were just looking at this, right?
Yeah, I was just looking at this page, but yeah.
Oh, yeah, yeah. Sorry.
No, it's all good.
Yeah.
Yeah, so it's a 4, right? 5, 0, 0. Yeah, total length. Whatever identification number flags. Yeah, oh, okay. That's still handy to have. Okay. All right, how do I do this? Okay, so byte array with explicit values. Okay, that's what I wanted. Okay, so we unsigned char buffer. What should we call? Let's call this IP buffer. Like this. Okay, so we need a 4, 5. Then we need 0x00. And then the total length, is that always going to be 3? Following header length. Okay, what's the length? Do we just default it to this 003C? Because the length would be the fragmented offset. Identification. Okay. How do we know the length? Because the length is going to be so the length will be, I'm assuming it's the whole thing, is the total length of the IPv4 datagram in bytes. Oh, okay, so it's the entire thing. So if we don't have anything, if we don't have any special message past this, the total IPv4, yeah, it'll be 03C. Oh, maybe that includes, in this case, it's going to include that. Okay, let's see what they have for this ping. Oh, they put 1C, so it's shorter. Type a message code header to payload. Okay. So they did a 1C. We could probably just steal that. And then let's take a quick look too. If we go back to Wireshark here, if we start this, and then we just go here, let's do another ping. Stop that. Okay, so what we'll see is here's our ping. Frame, Ethernet, this is what we want. So this says version 4. It says the header length is 20 bytes. Or, sorry, it's 84. Okay, so this is the length here, right? It's, okay, yeah, 4. Is that 84 bytes? This whole thing? ICMP. Sorry, I'm just trying to figure out this total length field here.
Yeah.
In bytes. Okay, so okay, so now I have to think for a second. So a byte, a byte is 8 bits. This is, can I change this to,
Apparently that's not always the case.
hexadecimal? Okay. So hex, each one of these is 1 byte because you get, hexadecimal is 4. Yeah, it's 4 bits. So each one of these is a byte. Okay, I had to remember that. Sorry, what did you say? It's not always 8 bits?
It's not always the case that a byte is 8 bits.
Oh, really?
Apparently it's architecture dependent.
Oh.
Like some architectures, I guess a byte is like 6 bits.
I guess you could, but I've never heard of that. That's interesting.
Okay, yeah. I just some video about C that I was watching. Buddy was talking about how, these kind of exceptions.
1, 2, 3, 4, 5. Okay, now I gotta get a calculator. Okay, so if where's our IPv start? So 84, 1, and then where does it end? And then this is it's got to be this whole thing. So 1, 2, 3, 4, 5. So 5 times 16 is what? 80, and then it's got these 2 at the end, 1, 2, and it's got these 2 at the beginning. Yeah, okay, so that's 84. Okay, so it's the entire message. So this length has to be from the start of the IPv4 protocol all the way to the end of the ping protocol. Okay. So we're going to have to figure out that length. Okay, but for now, we can, I don't know, I'll just leave this as a, we'll come fill this in. Maybe I'll put this as 99 just to remember. So I need two of these, 0x99. Okay, so that's the, so this is the version and the IHL. This is a type of service. This is the total length. Let's do this version, IHL, type.
Okay, so I have to do some calculation there.
Yeah, just so I can remember what everything is here. Type of service, which is 8. And then total length, th, which is 60. Okay. How can I do this on multiple lines? Can I do that in C? How would I write the IP buffer on multiple lines? Is that possible in C? I don't think it is. Oh, okay, cool. Yeah, that's what I want. So I could do this. Slash x slash. I'll get rid of these little commas too. Okay. All right. Now next up is, this will be the identification, which is 16. Flags, which is, oh, that's hard to read. Is that 3? It's only 3. And fragment offset, which is 16 minus 3 is 13. Okay. So this we know can be, oh yeah, what's identification? What does that do? Total length field, the identification field. Oh, it's just a unique identifier for that particular IP that we're sending. Okay. So if we take a look at this other fellow's thing here, what does he say about the identification? Doesn't say much about it, eh? I guess I should put this on the screen here. TCP IP checksum. Identification. Oh, he just hard coded his identification. So I guess we could just pick whatever. Okay, well, let's just hard code something for now and see what happens. What's a good identification? Sure, let's just do this A, B, C, D. Sure. And this can be 0. That I'm pretty sure of. Okay. And then the next thing up is time to live, which is 8. Protocol, which is also 8. And header check sum, which is 16. I don't know. How long long do you want this to live? 64? Sure.
64 seconds. 64 what? These are this is hex still, right?
It's the upper limit of the number of. Oh, this is number of routers through which the datagram can pass. Oh, interesting. 64 is recommended, though 128 or 255 is not common. Oh, interesting. Okay, so excuse me. What would be 64 in hex? Base 10 to hex. Oh, it's 40. Okay. Time to live, so this should be 40. Protocol is 01, and then the header checksum.
That's 64. What was that value again?
This one?
Yeah.
This is the time to live. So this is how many hops the packet will make before it gives up.
Oh, I see.
And to convert 64 from decimal to hex, in hex it's 40.
Right. Okay.
Forever.
So 64 hops.
Yeah.
That's a time to live. Yeah. And then what happens? It just stops.
Yeah, it'll just die. Like routers won't send it anymore. So it's just designed so a packet just won't live. So it won't keep getting sent. So if I remember correctly, what it'll do is every time this packet goes to like another router, that router will decrement this counter by 1. So eventually it won't. So if it just gets sent around, so it doesn't get in an infinite loop or just keep looking for an address that doesn't exist anymore.
Right.
Okay, this is the checksum. I think we can ignore it. Can we? Well, maybe we can't. Checksum is a pain in the butt, probably. Calculate. TCP checksum. Okay, IP header checksum. Here we go. It's easy to calculate. Oh, okay. This is all our values in IP header again added in 16-bit words and prepended with zeros in case the value is too short. Okay, so we basically add everything together. Do you calculate your checksum? No, you just hard-coded. You figured it out and hard-coded it. Ugh, what a pain. Okay. Maybe I need to break this out a little bit more. How would I do that? I have to add this all up. Okay, let's just leave the checksum blank for now. Let's just put 99 in there too. And then we can figure out the... so this is the source.
Consists of all values in the ICMP header added in 16-bit words.
Yeah, so I need to add... Yeah, I need to add all this all this stuff up. What a pain. Can I just not do it?
Oh, I see. Type of messaging code plus checksum placeholder identifier plus the sequence number, and then you get a subtotal. Negation with 0xFFFF uppercase.
Okay, well, do I have to break all these out? I didn't. Not int. Do I do this as unsigned? Sign char version equals, what did I say the version was? This x45. Okay, I'll just kind of repeat this for a bunch of these things. IHL. Is C like this? I can't remember what the C standard is for naming. Do you remember?
Like camel case or snake case or that sort of thing? I think what you had down there looks right with the not snake case, but the other one.
Like this?
Yeah, right?
I don't remember. That's fine.
Oh, okay. So it's got at least on Stack Overflow local variables, either one. So either camel case or the one with the underscore. I can't remember what that one's called. It's not snake case. The one that you're doing right now. Either one of those is fine for local variables.
Oh, okay.
These are local variables, I guess, aren't they?
Yeah.
Or are they global variables?
No, they're local.
Yeah. Yeah. And then it's got different, it says like struct as opposed to like struct names as opposed to struct members, enums as opposed to him. Yeah.
I wonder if there's a built-in structure for all this, actually, now that I'm writing all this from scratch. Oh, it's okay. Should we just write this from scratch?
Yeah. It's better this way. It's dirty, but verbose.
Type of service. That's just 0. Do, do, do. And the total length. That we'll have to figure out. Identification. Oh, it's just whatever we want it to be.
Oh yeah, that is snake case. Yeah. The other one I was thinking of was a kebab case.
Oh, kebab case.
Yeah, kebab cases with the hyphen separator.
Oh, I never heard of it called kebab case before.
Yeah, I don't know. That's
40. Protocol. 1. Okay. And then we need the... I don't know if I'm going to be able to combine all this. Source IP. Destination IP. Okay, let's see. I need to convert IP to unsigned char.
So yeah, it's interesting because char in C is an array, is a it's a byte array by default, I guess.
Oh, inet to oh, that's a lot of work. Isn't there just a IP thing? Because what did they write here? So 0A, 0A. Oh, so it's 10, 10. Oh, okay, okay. I see how that works. I think. Is that how that works? Oh, okay. It's just the integer number converted to hex. Oh, okay. We can handle that. So our source is our source. What did we say our source was? Here's our ping. Source. Here we are. So I can just copy this actually. Copy as C string. What does that give me? Let's see. Oh, that's really long. Did I copy the whole thing? That seems longer than it needs to be for some reason. It's a hex dump. Oops. Ugh. No, just copy the whole thing. I just want this part. Just give me this. Can I just copy all visible selected tree items? What does that give me? Nope.
Is it like a copy as hex?
Yeah, but I
Or
think
copy as
it's
probably not.
copying the whole thing. Value? Is that what it's gonna? No.
It's kind of see now. Yeah.
Oh, there we go. Okay.
Right. It's starting to come together here. This is useful, you know?
Is it starting to make sense? I know I've just been
Yeah,
just
like
babbly typing here.
yeah, yeah. I mean, um, it's definitely like some lights are starting to come on.
As hex. Okay, not exactly what I wanted, but close enough. All right, so this is, so if I go back to Wireshark, copy value. This is this IP address, right? And then this is this IP address. Okay, now I have all these. I could build the. Why did I do all this? All right, to build the checksum.
Checksum.
Checksum. All values in IP header added in 16-bit words and pre-appended with zeros. Oh, so I have to actually. So it's going to be this 16-bit words because these are. Oh yeah, okay, 16. Oh, what a pain. Okay, so int checksum, I guess, is.
So here's kind of a possibly a pretty dumb question here.
Yeah.
But so what we're seeing is like when you were just trying to do that copying thing, like you're going to like the that source IP, right? Um, and then we're seeing it in the hex equivalent in the as bytes. Um, now that should be equivalent in the sense that each character, so like say if it's called source IP, the property, so SOUR, each one of these letters is almost a byte. So that should be what the equivalent is in that table that we're seeing in the not here, like when you were looking at, I think it was like when you were looking at Wireshark,
Mm-hmm.
like the output there. You were doing some like you were trying to copy.
I'm trying to copy these hex
Yeah.
values so I don't have to.
So that's what I mean. Like here you're highlighting like destination address, right? On the left side.
Yeah.
And what we're seeing is so that's equivalent to like 8E FB, 2E, 4E, right?
Yep.
So what's the conversion here? Like it's converting literally the word's destination address colon
No,
and
no. It's just you just know because this is the protocol for an IP header. So you know
okay,
starting at byte. So this would be 30, 32. Oh, I guess it starts at 0, sorry. 31, 62. What's 62 plus 31? 93. So starting at byte 94, that's where you know the
yeah,
source address starts. There's no,
okay,
it's not like YAML or JSON where there's like text or anything in there. The
yeah,
only reason this text shows up is because Wireshark is smart enough to know that this is an IP header and it's done some of the parsing for us.
okay. So we know where it starts there, but but we're getting specific like hex values, right? Like you're getting
Yep.
8EFB.
Yeah, so I think if I understand this correctly, this 8E if you convert that to an integer, will be 142 for this destination address.
Right. Okay. Okay. Yeah. Yeah. And then the next one would be the 251 and so on.
Yeah, we could check that. So AE is
Like then
what
convert it
is
to
it
ASCII, right?
all right, no, so okay, I have to remember how all this works now. So you have sorry, give me a sec. So this is one 3 7 15. Is that how that works again? So if you want to write like the value 1 as a in 4 bytes,
Right.
right, you do, so 0 is this, 2 is this,
Okay. Yeah.
3 equals 1 1 like this,
Yeah.
and so on and so forth. So because basically you say if this, so you like a hex is 4 bytes, right?
Yeah. 4 bits.
Sorry, 4 bits. Yeah, thank you.
Yeah.
I guess we could just do it. We could just do it the whole thing. Might as well. Oh man, this is. Hopefully this is correct too. I think this is 7 is
1.
4. Yeah, 1 1 1, and then 8 should be this.
0 0 0. Right.
9 equals 1 0 0 1. Okay, let's just. And then you go to A, B, C, D, E. I need one more.
And F.
So this is really
like
11,
10.
or sorry, 10. 11.
Yeah.
12,
13, 14, 15.
Yeah, and we go up to 15 because we have 0.
0.
Yeah.
Yeah, so we start at 0.
Yeah, so this
So
will be 1 0 1 1, right? Because this is 8, 9, 10, 11.
Yeah.
Okay. And then 1 0 0. And then this is just all ones, right?
Right.
So that's what that looks like. So
Right.
if we have AE, what we end up with is 1 0 0 0. And then the E
1
is
1 1 0.
1 0.
Right.
And then if you expand this, so this is up to 15. Like this is sorry, what am I trying to say here? This is up to 15, but if you keep going, right, you can go so you go from 50, you go to
because you got lowercase and uppercase.
You go, yeah, but your numbers will go from 16, then your next one's 32, and then your next one's 64, and then your next one is 128, right? So this number here is 120. What were we trying to do anyway? What was our destination number? Our destination address was
127.
142.
142, yeah.
1.46.78. And
yeah.
then it was 8E. Let's see if I even did this right. Right, because this is going to be.
So that should give us that should be the equivalent to 142 as a number, as an integer. Right?
1, 2, 4, 8. Yeah, 16, 32. Yeah, so this is 100, and so this is 128 plus what did I say? This is 8 plus 8 plus 4 plus 2. So that's what this is really saying. Plus 8 plus 4 plus 2. So hopefully that equals 142. Does it? Let's see. So it's 30. Oh yeah, it does. Okay, cool.
It does. Yeah.
So
Cool.
That's basically integer math. That's unsigned integer. That's unsigned integers. How you convert them from bits to base 10 numbers, which is what we work in. So this is like a base 2 numbering system where you only have 2 digits to represent numbers, and we have a base 10, right? Because we go from 0 to 9.
Yeah.
And then
I was kind of following along till that very last bit where you went 16, 32, 64, 128. So to get those last numbers there, they're like 128 plus 8 plus 4 plus 2.
Oh, okay. So let's do this. Maybe like 64, 32, 16, 8, 4, 2, and then 1. So
yeah, where are these numbers coming from?
So this is what the position means in this number down here. So if this is a 1 here, you basically take 128. A 0 means
oh, right, because this is base because this is base 2.
Yeah.
Right. Because it's base 2. Yes. Of course.
Yeah, so the way you convert this, if this is a 1 here in base 10, it represents a 2. If it's a 1 here, it's a 4. And then you just add these wherever you see a 1, you just add those numbers up.
Yeah,
So
yeah,
128
okay.
plus 8 plus 4 plus 2 gives you 142, which is this first part of your IP address.
Because this is base 2.
Yeah.
Yeah.
Yeah, so you
That makes sense.
Yeah, that makes sense to you? Oh, okay, cool.
Yeah.
Yeah, and then, like I said, hexadecimal is base 16 because we have 16 characters.
Yeah, that's why. So you have to convert it to binary first, base 2. Or not, but like, yeah, binary, right?
You don't have to, but it's just easier for me. So
it's easier to work with.
Yeah, it makes my brain,
cool.
I don't know, easier to work with. So
yeah. No, I get it.
Yeah, so that's where you get this. There's AE FB equals 2. This is almost, so FF is the highest you could go, which would be 254.
Right.
So this is pretty close to 254, right?
Right.
So, yeah.
You can kind of like guesstimate a little bit just by looking at it.
Yeah.
Cool. Okay. That definitely makes a lot more sense to me now.
I'll just throw that down there in case we want it for some reason.
And then you just know based on the protocol, based on the like you're looking at the book and it's basically telling you how the protocol works so that you know that if it's in that location, then it's referring to this this destination address.
Yeah, and then again, back in the day, like memory and stuff was really constrained. So you weren't going to send like a giant JSON blob, or even nowadays, you wouldn't want to send that for every IP header. So yeah, basically these protocols will parse these bits out. Well, in this case, these aren't even full bytes, right? Like this is just 4 bits is this version value. And this IHL is just 4 bits. And this is a byte, and this is 2 bytes here.
Right.
So yeah, they just parse out the bits for this message, and each one of these bits means something. Or bytes, depending how big they parse it out is. And then, yeah, a source address is 32 because you got the 4 numbers in here. So
right, because you literally, that was the constraint. Like you had however much, bytes in memory to work with.
Yeah.
on the machine. Okay. Okay. I like it.
Yeah, so that's kind of interesting. Eh?
Yeah.
So there, you reminded me of my first university. There's a lot of doing this math. It's all
Right.
coming back to me now.
Yeah.
Okay, good God. Now we have to figure out. These are unsigned. Can I add unsigned chars in C? I probably can because C is crazy. So we got to figure out this. Oh, but it's 16-bit words. So I have to smoosh these two together. This is where I can't add these. I need to like combine them. How do I just combine?
Concatenate them?
Well, see, in C, you can't just easily concatenate something. You have to like allocate memory for it.
Mm-hmm. I was using that malloc method, right? I saw. Is that going to play in here? I guess it's not a method even. We're not talking about methods, are we? We're talking about because C, it's like structs and functions, I guess.
Yeah, there are structures. There's probably in the socket library, there's probably a built-in structure or that will help do some of this.
Right.
Use uint 16 to t and shift. Oh, I need to add IP header values to get the checksum. Just tell me how to do the checksum. I don't want to. It's gonna take forever for me to figure out how to add this all together.
The
Yeah,
heck is happening?
Can I do it using the existing unsigned chars? Probably not. It's probably gonna be gross. Okay, now it's using some crazy C math. So we're casting it as a unsigned 16-bit int, and then we're shifting it because type of service is okay. So I need version HL and type of service. Oh, okay, they're oring it. Oh, okay, that makes sense what they're doing. Okay, so we can use this. So do you want to see some more crazy bit stuff that you do?
Yeah.
Okay, so what we need to do for this god awful so right, this is to how calculate the IP header checksum. And probably people that do C all the time are screaming at me, but I can't remember how to do all this math. It's such a pain in the butt. So they have to be 16-bit words. So right, if you notice this is these are hex values. So each hex value is 4 bytes. So this is a 16-bit word.
Right.
Or a 16-bit integer, I guess is another way to think about it.
Okay.
So we need to take these two field values, version, or these three, version, IHL, type of service.
Mm-hmm.
That makes a 60, and then combine them into a 16-bit integer, and then add them to this total length. But total length, I think, is already 16 bits, so I think we're okay there.
So how do we combine them into a
Okay.
16-bit?
So this is you can see here. I just wrote out this as version IHL.
Yeah.
That's two fields. Technically, I squished those two fields together. But that will be
Right.
represented 40. So 0x45 is going to equal 0, 0, 1. No, 1, 0, 0. And then 5 is 0, 0, 1, 0, 1, right? This is
Right.
4. This is 5, right?
Yeah.
So, boom, that's squished together. But this is only 8 bits. It's an 8-bit word, not 6. It's not 16 bits.
Yeah.
So I need to combine it with the type of service. So the type of service, in this case, it's just all zeros, right?
Yeah.
So how do
So that's easy.
So how do I combine it so that this part is on the left-hand side of that?
So
So
you're trying to combine those two, is what you're saying. Like yeah.
What I want is this. 4, 5. 6,
Oh, right.
3, 4, 5, 6, 7, 8. Okay, I think.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is what I want as the final result, right?
Yeah. So you can't just kind of put one after the other.
Yeah. So what they're doing here is they're doing this bit shifting.
Okay.
So they're converting this. So do you know casting? Have you heard of the term casting before?
I heard it with types usually.
Yeah. So yeah, we're converting this type, which is an unsigned char. So a character is basically 8 bits in C. And unsigned just means if you have a signed value, the first bit tells you whether it's negative or positive.
Okay.
This is just I don't think we need unsigned. I think that chars are unsigned by default, but a char is basically 8 bits, a character.
8 bits.
And
Yeah.
that's from the old ASCII days where characters were always 8 bits. Now we use
Right.
Unicode, which is what, 16? I think even more. No, 32 or 64. So I think they're 32 bits Unicode now.
32 and 64, yeah. And there's unsigned.
Like that, yeah.
Signed.
So what we're going to do is we're going to take this unsigned, this version IL, this here, this 45, right? So we're basically going to take these bytes and we're going to make them into an unsigned 16-bit int.
Okay.
And what that's going to give us is 0x 0, 0, 0, 0.
So basically unsigned, we're not worrying about negative values, is what you're saying.
Yeah. Because if you have negative values, then your first bit has to be signed, right? I can just copy this.
Okay.
So basically, we're converting this character, oh, sorry, this is too big. We're converting this. What am I trying to say here? Oh, I put too many in here. So this is the final result. So what we want to do is we want to convert this into this 4, 5. That's what this first thing is doing. It's converting. We're casting this into this, which is going to look like 0, 0. Just 8 zeros, and then 0, 1, 0, 0, 0, 1, 0, 1. So basically, we're getting this, right?
So instead of 8, we're casting something from 8 bits to 16 bits. Is that?
Yeah, that's what this first part of this statement is doing here.
Yeah.
But the problem is we want these to be the most significant parts of the number. We want these on the left.
Oh,
And so what we
because the
do,
ordering matters.
yeah, because just like a number, right? Like
Yeah.
like if this is a decimal number, 38 is different than if you have
83.
if you have 03, that's different than 30, right?
Yeah, right.
So what we want to do is we want to move this to the left side. And that's where this
Yeah.
bit shifting comes in. So this will shift all the bits in your basically shift all the bits one to the left. So if you shift it 8 times, you're going to end up with this. And it just puts zeros in after it shifts to the left.
Okay. Oh, yeah.
So if we shift all these bits one at a time, like then if we shift them 8 times, we're going to end up with this. So that's what this
Right. Each one of them 8 times. Yeah.
that's what this whole statement does.
Right. Okay.
And then we also need to add this type of service. So type of service, in this case, it's zeros. So this is not the best example, but it's all zeros, right? So we need to add this on. Let's say type of service was just for like, it was like, I don't know, like this, right? Is that correct? Yeah. So it looked like something like this.
Hmm.
Now we want this value to appear here.
Yeah.
So what we can do is we could do what's called ORing bits. So if you OR a bit, which is usually this is this pipe symbol in C. Oh, it's
Yeah.
starting to do the autocorrect again. I thought I turned that off. I guess we've been so long it keeps going. So if you want to OR the bits,
Oh, yeah. So it'll be like 0 or 0 is going to be 0. 1 or 0 is going to be 1.
yeah. Okay, yeah, you got that. Perfect. 0 equals. So this is like the truth table for 0.
This is like the Boolean arithmetic.
Yeah, 1, and then this is 1. So this is like the truth table or Boolean arithmetic. Yeah.
Yeah. Wow.
This is 1, and this is 1, right? So this is OR.
Yeah. Yeah.
So what they're doing down here is they're taking this unsigned integer and they're ORing it with this type of service, which is again just 1 byte, 8 bits.
I see.
So you're gonna get this number. You're gonna get this basically, and then you OR it with. So the first part is always going to be zeros because there's type of service is only a byte. And in this case, it's all going to be zeros again, right? Because type of service is all zeros. But if we did our example like above here, like we wanted this, then our answer would be 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, 0, 0, 0, right?
Yeah. Yeah.
And now we've got our 16-bit word. Hooray! So that was kind of painful. Okay.
Yeah.
So that's what they're doing down here.
That is low. That is low level for sure.
Yeah. So let's put checksum equals 0. I need a semicolon. Checksum plus equals u init. Nope. U init 16. Version 8. And in this case, we want type of service. Okay. Great.
Oh wow, yeah, that's interesting.
I don't know if the rest of these is all correct. So then I want the identification, flags, and fragment offset. So identification is already a 16-bit word, so we're good. Flags and fragmentation offset is already also a 16-bit word. So we don't actually need to do... oh, here's the flags and fragmentation. Yeah. So we just need to combine those two together. We don't need to...
That's pretty neat. It's like when you put it that way, it's not really magic at all, is it? I mean,
Oh, I
it's
guess we need the total length in there too. Yeah. Um,
I mean, it's certainly arduous, but it's logical.
so the total length, we're gonna have to calculate the total length too. What a pain. So the total length would just be, I think we just, oh, but it's it's an array. Oh, I guess we do need to do this for each one, yeah. Okay, whatever, let's just cut and paste this and assume it's good. And then oh, go in there. Let's call this checksum. And 16t. Why don't you like that? Oh, is undefined. Oh, do I have to include something?
Get the library.
I'm on WSL. How do I get you in 16t?
Standard integer.h. It's the standard integer.h library.
Oh, is that what it is? Okay. Okay. And then it said something your current declarations of a few bugs, version, IHL, type of service are declared as unsigned char, but assigned to string literals. Oh, right. I should. Thank you.
Header. So yeah, okay. Standard library. Oh, these are okay. I see. They're all called header files. Provides fixed width and integer types and macros for their limits.
Oh, cool. Okay.
Yeah. Specifying exact width integer types like int 8 underscore t, int 16 underscore t.
Yeah, because otherwise you might get a random, like, I think most operating systems we declare an integer are 32-bit now. But back in
Okay.
the day, they used to be 16-bit by default. Oh, then I have to do this thing here. Oh, we're signing checksum to checksum. Why is it doing that?
Yeah, this is a great exercise.
Wait,
There's something to say for working from first principles, right?
yeah, it's very low level. How do I declare I need to return a t. What is it? No, int 16t. Calc checksum. Oh, but then I'd have to pass in all those values. Screw it. let's just, I don't feel like doing that. Let's just leave it as all one big method for now. Okay, so we got the checksum. Okay, well, let's see if some, because the other thing we're missing, we need to calculate the length of this whole IP packet. Okay, so we can get rid of this. Or maybe put it at the bottom. So we do need to calculate the length of this whole IP packet. Which is going to be, I don't know, I'm just going to ask it for now. Okay. How do I calculate the entire length of the IP packet for the total length? Oh, no, I did this total length. Oh. Or data sum, I guess it's not a packet. Datagram. Okay. Oh, I guess we always know it's 20 bytes. Okay. And bytes. Okay, so for now, we don't actually have any ICMP stuff. I'm just going to send something. So I'm going to put the length as 20. Just going to be 0, 0. And then what's 20 is... man, hex math is hard.
So F is 15. Like F0 would be 15, and then
so F1. No.
you're trying to get 20. So
yeah.
so F4.
F4.
Yeah.
No, that's too big.
That's too big. 0F is 15, right?
Yeah.
And then, oh, sorry, then 1F 16, 2F 17, 3F
Oh, yeah.
18, 4F 19, 5F, right? 5F?
Sure, let's try it.
Okay.
Okay, and then we'll send this and we'll see. Okay, so now I just have to build this buffer. Okay, so the buffer is going to be... version IL plus total length. I think I could do this. Is that going to concatenate them? Okay. How do I concatenate the unsigned chars into one buffer? Boom.
MCPy.
Oh yeah, I guess I create a buffer of 20. Okay. So I have to declare a buffer of 20. Great. Oh, and then add them in there. Oh, interesting. So what is it suggesting here? It's suggesting start an offset.
What is going on here?
It's an unsigned char. IP buffer. Oh, this is the starting point. So, what does mem copy do? Mem copy. No, it doesn't have it. Do I have to include? Oh, include string.h. So mem copy. Copies so many bytes from the source to the destination. Okay. Oh yeah, and then offset. Okay, good enough. Let's. Oh, I just want to see if anything's actually going to work. Oh man, we've been recording for a while.
Yeah.
How you doing there?
Yeah, I mean, it's more like I'm getting to the point where my brain needs to kind of process a lot of this, you know. I'm hitting a buffer overflow.
Size of IP buffer. Okay. This is probably pretty gross. There's probably much nicer ways to do this. Okay, so then we're just building our buffer here. And let's just see what gets sent out with Wireshark. Okay, so oh, that's my Wireshark command. Okay, so where's Wireshark? There it is. Oh, okay, click and drag. There we go. Okay, and then make. Let's see what Wireshark did. That looks like a lot. Let me move these over a little bit. See if we can get these to happen at the same time. Okay. Oh, just did the ack and knack again. Okay, no, I think we got some stuff in here. Let's see. Let's see what we got going on here. Okay, so this is what we sent. This is the... Oh, okay, so this is what we actually sent out, I think. This is what we sent here. Version 4. The destination IP. Oh, it says it's 2189. That's the wrong one, isn't it? Oh, yeah, we got something wrong. Okay, cool. Oh, did I put the checksum in here? Oh yeah, the checksum's in there. And then the length, yeah, we put it to that. Okay, let's see. Total length, it says it's 52, but that's not right. Okay, interesting. Okay, so 45, 00.
Oh, I think I also made a mistake with that 20 in hex is 14, not 5F. I'm sorry.
Oh, all right. Let's try changing this. 14.
Yeah.
Okay, let's see. Whoops. Let's see if we can get this to pop out a little more. Yeah, put all the TLS in there. Okay, so sorry, this is what we sent. So version 4. I think this is what we're trying to say. 4.5, that's fine. And then we should say 0014. No, but it's not 0014. Oh, that's kind of sad. Total length. Oh, that's pretty long. Why is it so long? And then we got a response back. And then we sent another one. $45, 000014. We got a 92 again. Oh, there's our IP address, right?
Yeah.
Source. Oh, our source is wrong, though. This is what we're putting as our source. Now I don't know what's going on. Sequence number raw.
Yeah, it's showing the source is 20 point something.
Yeah. Oops, too far. Protocol. Yeah. So maybe let's just see one more time. Yeah, then that's I'm trying to look up this IP address, it looks like.
Hi. Oh, thank you. Thank you.
Okay. Oh, I muted you there, Omar.
Yeah, sorry about that. I should have put it on mute. Somebody just showed up at the door.
Oh, it's all good. We'll wrap this up soon. Yeah, we've been going for a while. Yeah, this has been fun, though.
Yeah.
I'm just trying to figure out what's getting shown here. So is this a correct source? What's our source? There we go. That's the correct source. It's not the right destination address, though. For some reason. I wonder.
Something in the the calculation with like the casting and the bit shifting?
Yeah, it could be.
Can we get a debugger on this?
Do some print lines there.
Print line.
Oh, the header checksum. Which one am I using here? Oh, it's the wrong header checksum. Okay, let's don't want this. I want this checksum down here. Oh, no, now it dumped. Oh, because that's not a unsigned char. That's an int. And I want to copy. So I'm copying into there. Is this only for oh yeah, this is only for strings. Okay. How do I copy the uint16 checksum into the buffer? Probably have to cast this or something, maybe. Because what happens here, I think, is when I try to memory copy this, it assumes this is a string, and it assumes its strings end in a null, but this one didn't end in a null. And
Okay.
of course, it totally borked. Okay, let's see if this works. Oh, I guess I can just do this here. Well, that's fine. Let's just leave it. All right. Wireshark. Come on, show us something here. Oh, what do I need? Oh, right, okay. Okay, that worked. Hooray. Let's do this. Run you again. Oh, it's still the wrong destination. All right, what was our 142? Oh, that's a 140. That's better, I guess.
It's warmer.
It could be something else it's trying to send to.
Yeah, I mean that's the thing. How do we know we're looking at the right thing?
What did we put? 14. Yeah, I don't see our total length anywhere in there. Wait, that's not the right. Oh, this is wrong for the total length, though. Oh, that's wrong. Yeah, we want.
No.
Because we don't want the 0 to shift over. Like this. Or is that right? Oh no, right, that should be right. Actually, sorry.
It's all right.
Yeah, that's right. Okay, 0. Well, let's try one more thing and then we'll call it. I'm just going to write. How do I write out the IP buffer as hex or bytes or bits? Right. Let's see what this says.
Hmm.
Okay, let's see what that gives us. Okay, so yeah, we're sending the right thing. 14. 0, 41. The checksum's going to be whatever it's going to be. AC 16 CD FC. Oh yeah, that all looks correct. Okay. So why can't I see the IP request in Wireshark? I keep seeing. What do I see? TLS. TLS. Oh, okay. It doesn't let you create your own. Oh, okay, okay. Okay. Yeah, I love reading how it like thinks sometimes. Okay. Okay, it's ignoring our. We worked so hard to make that IP header. Okay. Socket raw, IP protocol raw. Use send to with a destination address. Oh, okay. Set socket options, IP protocol. Oh, send socket IP buffer. Struct socket address. Where's the socket address? Okay, let's try this one real quick.
I mean, we're not using send to. I don't know if that's.
Raw sockets need send to with socket adder in. Oh, okay. sent to with a destination address. Or is your IP header correctly? IP, without this socket option, the kernel strips your custom IP. Raw sockets need send to. Okay. Why do they need send to though? We have the destin. Why do I need send to? I have the destination IP in the IP buffer. Oh, great question. Thank you. Oh, placed inside the Ethernet frame. Yeah, that's fine. Oh, okay. Okay. Well, let's try it.
This is specifically because you're running it in, like, this is a Windows specific thing?
No, I don't think so. The reason it's not working?
Yeah, like the reason why it has to it's saying something about framing it for the kernel, the Ethernet.
So you're asking about
An Ethernet frame?
yeah, so the Ethernet protocol, so basically for it to get from one computer to another, it has to go over Ethernet.
Yeah.
That's like an even lower protocol that I don't think we can actually touch here. That's all handled by the operating system.
Yeah.
So if you look at this message here, here's like the Ethernet protocol part.
Right.
So this is how Ethernet communicates, like how one computer on Ethernet would communicate with another one.
Mm-hmm.
I guess these are the MAC addresses. Oh, it's going to have to compute the MAC address? Is that what it needs? Oh, right. Kernel needs to build the Ethernet frame itself, which kind of know the interface next. Oh, okay. So yeah, it needs to figure out the MAC address. Okay.
Okay.
Sending it to. Let's see. Oh, all compiled. Do we get to see anything? No, doesn't look good. Oh, maybe this is it. Is this our error? Oh, maybe we didn't wait long enough for the time for the timeout. Error. Huh. Still didn't seem to do anything.
Well, maybe a good time to
To call it? Oh, I was hoping to get some.
yeah,
Yeah, it's probably time to
get
call it.
us
So
get a part two on this one.
part, maybe many parts. Yeah, I don't
That's
see
all right.
142. Well, I don't know. Hopefully, this made some sense to you, Omar.
This has clarified a lot
We did a lot of
already.
math.
Yeah.
But yeah, thanks for suggesting this. Hopefully, others found this useful. This is kind of worried about that I would struggle through a bunch of this, but yeah, this is still fun. I always thank you for suggesting this to me.
Thank you for being game with this, and it's this is where the fun happens when you get into these things and you just kind of dive in and I'm sure we'll figure it out.
Yeah, I might have to play around with this a little bit this afternoon. So yeah, well, thanks everyone for watching this really long video. How long did we actually record for? Like almost 2 hours here. Hopefully you found some of this useful. If you have any suggestions, of course, everything as usual, you can send an email to ask@SaturdayMP.com or leave comments or put questions down below. Yeah, if you have things you want us to fumble around with in future videos, again, constructive feedback, use the email or send comments, stuff like that. Thanks again, Omar, for suggesting this. And thanks everyone for watching. This was a lot of fun. I don't know, it's fun to record these videos, something a little bit different than work. A little bit of like assignment and investigation and research. Kind of reminds me of the good old days of university. So yeah, thanks again, Omar.
My pleasure.
And we'll catch everyone